Hey, being Alex. So as you've probably already heard from my message that I sent out the other day, we're cutting this back to 1 day a week. This is what Putnam County Schools wants us to do. So you'll get a lesson from me every Monday for calculus. Okay, so be ready and looking for that. So today we're going to talk about how we will use integrals. Okay, we're not directly going to be using integrals today, but we're going to try to introduce the topic. Integrals are mostly used for finding area under curves. So what we're going to do today is find the area under curves. What we're doing today is called upper and lower sums. Okay, so we're going to use those summations that we talked about late last week and talk about them here moving forward. Okay, so this is the situation that we've got set up. I'm graphing the line negative x squared plus 5. I'm going to give you a rough sketch here so you know what I'm talking about. So it looks like this. But then I've got three things that are bounding it. So it's bound by the x-axis, so it means it goes no lower than the x-axis, so all of this is useless. It's bound at x equals 0, so all of this is useless, and then it stops at 2, okay? So it's really only talking about this small section on the inside right there, okay? I know this is a rough sketch. I'm erasing it because I don't like the way it looks. I took a picture of the book's actual drawing over here to the right. So just giving you an idea of what's going on, what we're kind of looking at. Okay, so what we have to do in order to find the area, we can't find the area under a curve. It's just not possible yet. Okay, so what we have to do is we have to put a bunch of little triangles in there. I'm sorry, not triangles, rectangles. Have to put a bunch of rectangles in there and then find the area of them, and then we'll just add all those areas up, and that'll give us the area under the curve, or at least it'll give it close to us. Okay, so if you look over here on this picture to the right, we have 5 rectangles set up. Okay, and it's relatively easy to find the heights of these rectangles. If you notice, they're all 2/5 wide. I'll talk about that in a second. It's easy to find the heights of it because you could just plug in the function, f of x is negative x squared plus 5, whatever your x value is, and it's going to output you the y value. So it's going to output you how tall it is. Okay, and it would be easy to do that for 5 of them and then just find the areas and add them all up. But what if we start making these smaller triangles or rectangles? Because the smaller your rectangles are going to get, the closer you're going to be to your actual area, because you're going to lose this dead space in here. So if you notice, that's not included in any of these rectangles, okay? So if we make smaller rectangles, meaning like if I would start cutting these in half and then no longer have 5 of them, I'd have 10 of them. Okay, my rectangles can come up a little bit higher and be a little more accurate. Okay, so then this one can come up a little bit higher. Okay, so that's what the situation here is. But it would be insane for us to just do that over and over and over again without just setting something up. Okay, so we want to set up a summation so that what if we have like 50 rectangles in there? Okay, so it would be tough for us to find the individual areas of all of them and add them up. So we're going to set up a summation. Okay, so our summation is going to start at 0, obviously. 1, I'm sorry. Let me rephrase. We're going to start at I equals 1, but our picture is starting at 0. Okay, we're going to go to 5. The reason that we're going to 5 is because we have 5 different rectangles here. That's the way that we've chosen to set them up. Now, we have to talk about how i's compare over to our picture, okay? So, I equals 1 is actually this spot right here where it says 2/5. I equals 2 is there. I equals 3. I equals 4. I equals 5. Okay, so these are our i's all the way across through here. Those are the numbers that we're plugging in. So when we set something up, we have to set it up to get us to that spot. Okay, so basically we can already say that the widths of all of these rectangles are 2/5 because we go all the way to 2. This spot out here is 2 on the axis. Okay, 10 over 5 is 2. So we go all the way out there. We know we're out to 2, and we cut it into 5 spots, 5 different rectangles. That's why we have 2/5 as our width. So we know if we're finding area of rectangles, we got to do length times width. So width is already 2/5. So all I've got to do is just find out what the height is, okay? And I'm going to find out the height by plugging in my values here. So I'm going to plug 2/5 in to the function, and that's going to output me how high that is, okay? But I can't just do that every time. because my number changes. I've got 4/5, I got 6/5, I got 8/5, and in order to not have to do this 1,000 times, I have to be able to put that into the function somehow. That's how the i's come into play. So 1 times 2/5 is 2/5, but I equals 2 right here. If I put 2 times 2/5, that's 4/5, so that gets me my 4/5 number. I equals 3 here. 3 times 2/5 is 6/5, so that gets me up to there. So basically what I want to use over here is 2/5 times I, okay, because that's going to give us the height. But that's not exactly the height, is it? Okay, no, it's not. We have to actually find f of that, okay, so let me erase. We have to plug 2/5 I into our function, so we'll multiply by f of 2/5 I, okay? It's not bad, I promise. Okay, so now as we start down through here, we've got it set up. We can do our summation, okay? So I'm going to actually put this into our function. So we've got 2/5 still. We're going to put 2/5 I into the function. So that would be negative 2/5 I squared plus 5, okay? 2/5 I squared, we're just squaring everything there. So it's 4 over 25 I squared. Okay, and then that negative, and then that negative stays with it because it was outside the parentheses. Okay, and then we still got our plus 5. And I've got this 2/5 out front, and when I distribute it, okay, when I distribute, I should get 8 over 125 I squared, and then 2/5 times 5 is just 2. Okay, so so now I'm ready to take my summation. Okay, so I'm starting at 1, I'm going all the way to 5. Remember last week we can break these up. The negative 8 over 125 can go out front. And then we've got the summation of I squared plus the summation of 2. Now this is going from 1 to 5. And for I squared, the formula is n times n plus 1 times 2n plus 1 all over 6. So that's 5 times 6 times 11 all over 6. Those are going to cancel. This is just 55. And we got to multiply that by negative 8 over 125. And then out here, my whole number one, I'm going from 1 to 5. It's just multiplying them, so it's 10. Okay, so when you actually do the math on that right there, it outputs you 6.48. Okay, so trust me on it. I did it just a second ago. That's what it outputs you, 6.48. Okay, now, that's not the actual area, okay? Because let's go down here to my second picture. Okay, as part of my second picture, if you notice the rectangles are set up differently. Okay, on the top picture, look at my top picture here for just 1 second. The way these are set up, we go from the right edge of every rectangle up until it touches the arc and then cuts back over to the 0, okay, or to the next spot. If you look at 4/5, it goes all the way up until it touches the arc and then it goes over, okay? On the second picture down here, it's not that way, okay? This picture goes all the way up on the left side of every rectangle and then cuts over to the right. If you look at 2/5 here, it goes up on the left side of the rectangle until it touches the arc and then it crosses over. One more. 4/5 right here. It goes up on the left side of the rectangle till it touches the arc and then it cuts over. Okay, so with our eyes still being 1, 2, 3, 4, and 5, to find the height of it this time, we're no longer plugging 2/5 into the function because that would not get us the correct spot. Plugging 2/5 into the function would get us this spot right here, which is the height of the second rectangle. Okay, so what we have to do is we're going to set up the exact same thing, but instead of doing just regular I, we're going to do I minus 1 to make this because we're moving it back. Essentially, we're saying I equals 0 right here is the spot, and instead of being at 2/5, we want to go back 1 to I equals 0. Okay, so I'm going to set up a summation for that. You can still see the last one in the top of the picture there, so pay attention to it because it's close to that. It's the summation from 1 to 5. Our width is still 2/5. Okay, remember we got 2/5 because it's 2 wide and we cut it into 5 spots. But this time we're multiplying by f of not 2/5 I, but 2/5 I minus 1. Okay, which we'll simplify that in a second. Okay, moving down, if you want to make that look better, I would probably write this as 2I minus 2 over 5 for the time being, for using it in the function, because I've got to put it into the function as being squared. So I've got 2/5 still, we're multiplying it by 2I minus 2 over 5. That's all squared. And then should have, nope, that's all I got in there. All right. Oh, the plus 5, there it is. Okay. So now once I get down to it, I still got to start squaring stuff. 2I minus 2, if I start squaring that, obviously the top and the bottom get its own square here. So squaring 2I minus 2, 4I squared, minus 4I would be minus 8I, and then plus 4, all over 125. Okay, still got the plus 5. Then we got to do 2/5 of all that. So multiplying everything on top by 2 would be 8I squared minus 16I plus 8. And then the bottom times 125 times 5 is, I don't know, 600? Yeah. 625, sorry. All right, and then plus 2 out here on the end. Because 2/5 times 2. 2/5 times 5 would be 2. All right, so if you want to start breaking stuff up, here's what I'm going to do. Remember we're doing the summation of all this, so I'm just going to do 8 over 625. I know that reduces, but I've got the summation of I squared, then minus 16 over 625, the summation of I, and then plus the summation of 8 over 625. Okay, and we can multiply that. Also, then I've got plus the summation of 2. Okay, so I'm going to go through all of that. I'm not going to bore you with it. It outputs you 8.08. Okay, so here's what we have to talk about. The first one outputs you 6.48. Second one outputs you 8.08. So the thing is, the area of that under that curve is somewhere between 6.48 and 8.08. If I average that, it's 7.28. Okay, so it's somewhere in that ballpark, but we can't really say that for sure. What we would need to do is, like I said a little bit ago, start making more rectangles. So what you would want to do is repeat this process and go through and cut it to 10 rectangles. Okay, if you see I'm drawing on the top picture here. Okay, cut it to 10 rectangles, each being 1/5. Okay, you would do the 2 out here and divide it by 10. Okay, so 10 out of 10 basically. Or 20 out of 10 rather. And then do the same on the bottom one. Cut it into 10. It's going to get you a lot closer. So then basically everything over on the math side changes a little bit, but not too much. Okay, so the problems that I've decided to give you is 299, 25 through 30. Okay. I know this is a lot to take in like a 15-minute video, but it will be okay, I promise. The ones that I've given you, it tells you how many rectangles to do, so you don't have to worry about that, and it tells you how to bound it and everything. So do your best. Again, you won't be hearing from me until, again, on next Monday. So just do this, turn it in, and you should be good to go. So just let me know if you need anything. Again, just do your best on this, I promise. All right, I'll see you guys.